Okay with that. I like the idea.
I already knew you were going to have that concern, so I am prepared for you.
Monday?
No. All right. Any questions on your homework? All right. We have a quiz on Monday, and yes, I will give you a practice quiz. The practice quiz will be exactly like the real quiz. So if you blow this off and you do poorly, you have yourself to blame. I said the quiz is going to be Monday, it'll be the first thing we do. Don't blow this off, right? All right, homework tonight or over the weekend. With a big exclamation point.
Yeah.
That's what I do on my slides too. Go to calendar something.
Oh, really? Is it actually good? Mm-hmm. And they have the dates written on it, you have to write it by yourself, so you can start it whenever and finish it. That's pretty cool.
Unless you're looking forward and you're like, oh, when is the next holiday? All right, here we go. Remember yesterday we did 2 of the 3 things. Today we do the last thing, which is called establish an identity, right? On a normal, Monday through Thursday, I would show you a quick review of what we did yesterday. So I have these in the slides. I'm just going to show you or remind you of the 4 arrows. So always one technique is to change things. You change things, especially cotangent, tangent, with the hopes that something cancels. That's arrow number 1. Arrow number 2 is multiply by the conjugate. Maybe that works. We'll see that today. Arrow number 3 is you got fractions, add or subtract. We'll see that today. Hopefully something cancels. And an arrow number 4 is if you can factor. Now, the issue with all of these is I'm not telling you which one to do. And by the way, you'll never know which one to do until you actually get into it. Okay. I had examples of all of them, but I'm going to skip. They were the same examples as yesterday. I'm just going to skip to the new stuff. And we will do all 4 arrows today in some form or fashion. Okay. Example 4. So what are we doing today, right? Today we are doing established identity. It's just 2 words, right? What you need to do is pretty straightforward in the sense of I know what I'm supposed to do. It's the doing it that requires some thought. This is literally in your book. Last sentence says, the selection of appropriate basic identities to obtain your desired results is learned only through experience and lots of practice. They're basically telling you is, well, you're never going to know what to do until you have a lot of experience doing this. So expect to run into problems when you do these. If you get frustrated because you're not getting to the answer, well, then it's because you're not experienced and you don't have a lot of practice. The more practice you do, you get a better feeling for maybe this is the path I should go down, right? I'm going to do 7 examples today, right? You'll see 7 examples. So we'll see all 4 arrows at least once or twice, right? So general things to keep in mind, right? Should I distribute or should I not distribute? Always look at the end goal in mind, and it kind of points to should I distribute or not. If the end is in sight and you can already see that end and it matches what you just wrote, maybe you shouldn't distribute. Maybe the other thing cancels. Okay. Should you factor or not? Well, once again, look towards the end. Right. If you can see that something would happen if you factor, then you should probably factor. Right. If you can't see towards the end, you're like, I don't know, I can't see what you're talking about, or I can't figure out what I should do next. Well, then factor, see if it works. Go down that alley, right? Same thing with distribute. If you can't see that's what I should do or not, well, then try it out. Maybe it works, maybe it doesn't. Should you rewrite? Should you keep it the same? Who knows, right? Choose a path, go down it, see if it works or not. So when you're doing all of the top three, always think about where you're going. And that kind of typically points you in the direction you might want to go, right? You also have to have a good command of your basic trig identities that speeds things up. If you've got to think this through, that what was one? Was that sine squared plus tangent squared, or was it sine squared plus cosine squared? Then you kind of slow things down. All right. Today we're going to be doing something that's called established identity. All it means is show that the left side equals the right side. Show that the right side equals the left side, either one. Typically, we work on the most complicated side because that's the side that you have the most options with. Distribute, factor, rewrite. If you work on the least complicated side, you only have a few options. And it's harder to turn something least complicated into more complicated than it is to turn something most complicated into something least complicated. It'll make sense when we do a few of these, right? So if you're confused, all I'm saying is today we're going to turn the left side to the right side or turn the right side into the left side. We're not moving things across the equal sign. Everything stays on one side, but we got to convert it or simplify it or change it into the other side. Exactly. How many examples did I say we're going to do? Here we go. Example number one is the easiest one. Priscilla, what are you thinking? Which side do you want to work on? Left side, right side? Why left side, not the right side?
Yeah, work on the most complicated.
Work on the most complicated side. So there's only one thing on the right, there's two things on the left. So the most complicated side is the left. Okay, now you're on. Give me something, anything. We're doing what we did yesterday in terms of simplifying, but I got to show that the left side equals the right side. Well, just give me some options here. What can we do?
1 over sine.
She says I could turn cosecant into 1 over sine. Okay, I'm looking towards the end goal. Does that say 1 over sine? Okay. So is that the path we should take? Maybe. That's the thing. We aren't going to know unless we think going forward. Maybe Ish is seeing something. Nothing wrong with what you said, Priscilla. We could write cosecant as 1 over sine.
Well, I don't know, but I might make this complicated, but I was thinking 1 over sine theta multiplied by sine theta over cosine theta. The signs cancel out, which leaves
Okay, stop,
1 over.
stop. So do you see what she said?
Yeah.
She said she's thinking two things. You thought of one thing. She's thinking of two things because she said, look, something cancels, right? So maybe that's a good thing. So let's take that path, right? We're going to work on the most complicated side. You were correct about that. So that's the left side. So there's the left side there in black. And we said that cosecant and tangent can be written with these two identities right here. Tangent is sine over cosine and cosecant. More importantly, since they're multiplied together, this is what Ish realized, the signs would cancel, right? So maybe you're starting to see the matrix here, right? So yeah, but that doesn't say secant, that says.
But 1 over cosine theta is equal.
And this is why having a good command of your trig identities allows this to be an easier process. If you didn't have command over your things, you're like, well, why would I want to write it as 1 over cosine? Well, 1 over cosine is secant by definition. So having a good, understanding of your trig identities, the end goal in mind is what makes these somewhat easy. This is as easy as it gets right here. I don't think anyone would ever done anything other than this right here. You would have stumbled on the answer. If you mess with the other side, the secant, guess what the only thing you can do is? 1 over cosine, and you're like, well, what do I do now? And it's like, it's really hard to work on the least complicated side, try to turn it into the most complicated side. Okay. Does it? Is it box on? It's box one, okay. Okay, well then that's a mistake. Thank you for making my slides better for next year. All right. Number 2. Okay, pay attention to this one. Thoughts?
Well, the normal one equals one, so if it's sine squared theta plus cosine.
Does it say
theta,
sine squared theta?
Says.
Doesn't say. So correctly thinking, if it said sine squared theta and cosine squared theta, we could write one and we would be done in one step. But it doesn't. It says, so we better think of other identities. What other identities we got? Yeah, but that's, once again, that's just theta. It doesn't say negative theta. Do we have any identities with negative theta? Open up your books. Look at the last page. Do we have any identities with negative theta? By the way, there's plenty of identities there, but of the ones that we've done,
Sine, parentheses, negative theta.
what those are called,
Even odd.
we have the even and odd identities, right? We have the even and odd identities, these ones right here, which says that if you have sine of negative theta, what do? The negative front. If you have cosine of negative theta, you just completely get rid of it. So we could use that. Okay, I'm going to tell you a hint right now, right? If you have an x and you multiply it by an x, what do you get? You get x squared, right? What if I had an x and I square it? What do you get? So both of these equal exactly the same thing. So if I put the x in parentheses and I square it, I still get x squared. Well, I'm going to show you a step before we do our odd and even functions. I'm going to do that right there. Instead of writing as sine squared negative theta, I'm going to put parentheses around the whole thing and square it. Now, some people would look at this and they'll say, but a negative times a negative is a positive. We're not multiplying a negative times a negative. The negative theta is inside the word sine. I'm squaring sine. This will become more important here in just a second. Is everyone okay with this step? You're going to need to use this again after this. So if you see a square, you can do this. These are equivalent statements now for the left side. Now apply the odd and even thing. It said if there's a negative for sine, what can you do? Bring the negative to the front. If there's a negative theta for a cosine, it goes away. Do you see what I wrote? Now watch this magic. It says square what's inside the parentheses, but now the negative is not on the inside. The negative is, so now it is a negative times a negative, and a negative times a negative is. And now we get exactly what we wanted was. This is a classic technique of what happens when you have a negative angle inside. Treat it as an odd and even function. If it's sine, the negative goes to the front. If it's cosine, it goes away. If it's tangent, it goes to the front. Same thing with cosecant, secant, cotangent. So yay, that one was easy once you saw this trick. And it is a trick. Tonight for homework, you'll have to use that trick. So the trick was, I can rewrite sine squared negative theta as parentheses sine negative theta squared. And the reason why we write it like that is because the very next thing we can do is bring the negative to the front, and when you square it, that would be a negative times a negative. Because ultimately, we knew we were going to try to get to 1, and we kind of knew what we were supposed to do. Did that make sense? We're going to use that technique. Again, example number. Oh, did I put my box number right this time? Yeah, box 1. Okay. So it's just the first one that's messed up. Okay. We just did that trick. Now you know what to do. Let's do it again. By the way, which side we want to work on? Left side or right side? I would say the left side. Okay. What was the... Wait a minute. This isn't the same. What's different? What's different for this one? Okay, the bottom isn't squared. What else? Let's go back to the previous one. What's different? Fraction. What else is different? There is. It's the same thing.
It's subtracting.
It's a subtract instead of a plus. Do you see that? Did you say that?
Yeah.
Oh, I'm sorry. You were right from the start. Okay. Yeah. So even if I change it to sine squared plus cosine, which I can, it doesn't say sine squared plus cosine. It says sine squared minus cosine. So that's a problem. But guess what? I'm going to go down that path. Watch this magic. I'm going to do the same technique. I'm not messing with the bottom right yet. I'm messing with the top. See what I did? I'm just messing with the top. Same technique as last time. Okay, now for the entire fraction, for the sines, where does the negative go? In the front. For the cosine, where does the negative go? Just disappears. You see what I did? I did it for the numerator and the denominator, for sine and cosine. If it was sine, I moved the negative to the front. If it was cosine, I made it disappear. It already had a negative in the middle, so for cosine, we're still stuck with that negative. Okay, if we square this now, the top negative sign goes away. And for the cosine, unfortunately, it's still minus. And so it looks like, although I've done something, I'm still not even remotely close to the end.
Well, couldn't you do the same thing to the one on the bottom?
Well, it's not squared, so I can't do it. Okay, do you remember that one technique we used yesterday when Ish said, well, if you write it that way, it makes it really clear. Do you remember that? Ish, do you remember that? I want you to look at the numerator and tell me something smart. Look at the numerator and tell me something smart. What? Yeah, nothing cancels. Look at the numerator and tell me something smart. Okay, I'm going to show you what I showed you yesterday. And Ish said, well, now I understand it. I showed you that.
Oh.
And I got the same response yesterday. Oh, factors. So how come you didn't see it here?
I don't know.
You got a perfect square, sine squared. You got a perfect square, cosine squared. Those are both perfect squares. And a minus in between them. If it said x squared minus 3, it factors to. If it said x squared minus 9, it would factor to what? If it said x squared minus 9, it would factor to x
minus 3
and
x plus 3.
But it doesn't say that. It says this. So what does that factor to? That's what it factors to. And now your spidey sense should be tingling. They don't cancel. Why not?
Oh, never mind. Just kidding.
Well, look at it longer. Maybe you'll figure something out. It doesn't cancel the way it's written right now. No, they don't. They don't cancel. Top says sine plus cosine or sine minus cosine. The bottom says minus sine minus cosine. Nothing cancels. But you can figure this one out. You want a hint? Look at the bottom. Do something smart with the bottom. Yeah, it's not squared. Look at the bottom. Does the bottom match anything on the top? Doesn't match anything. Is there something we could do to make the bottom match the top? Flipping it wouldn't do it. How would we do that? Do what? Not the inverse.
Whatever you do.
No, we're not going to multiply by the conjugate.
That magical thing.
There's something really simple that we could do to the bottom so that the bottom matches the top. Come on, Matt or Nick. Say that again. If we multiply by 1, would it change anything?
Multiplied by
How about instead of multiplying,
divide.
we divide just the bottom, by -1. What would happen if we divided just the bottom by -1? We would get that, right? Is this still the same as the bottom? fact, I just factored out a -1 is what I did.
Then you can cancel.
Now I can cancel, so you need to be ready for this. When they don't perfectly match, and if you could divide or factor out a -1, this is always a trusted technique. So now it cancels. Okay, what are you left with?
What is that?
What happened to the -1?
Oh, well. Oh, do you have to multiply?
Just put the negative in front, yeah.
Okay, now what?
Just put it in
And what would you be left with?
negative sign theta.
Isn't that what that says?
Yeah.
It's just
Mhm.
flipped.
It's just flip.
It's flip, but we can flip it back around, right? Did that make sense?
Mhm.
I did not say these are easy, right? These are challenging. What example was that?
Mhm.
Got 4 left. Anybody's head hurt? You hurt? Does it hurt now?
What, could you look at?
Because most people, when they do this stuff, they feel like they're banging a nail in their head.
What was the picture? Nail in his skull. My head always goes like that, so.
Are you okay where I moved this -1 to the? Okay. Good? All right. Number 4. All right, you're on. Somebody tell me something smart. Waiting on you guys.
Cotangent could be written
She says cotangent can be written as 1/tan. Is that the path we want to go down, or we want to go down another path? How should you determine whether this is the path we should go down? Look at where we're going. Where are we going? We're trying to turn the whole thing into tan. You have 2 options, right? You could turn cotangent into,
No, it's not that.
you could turn cotangent into, that's what her suggestion is. You could turn it into cosine over sine. Is that a path we want to try? Like, I'm trying to say, how do you know which path to go down? We could turn cotangent into cosine over sine. Is that a path we want to pursue? I'm looking at the end, and what does it say it's supposed to turn into? So shouldn't we probably keep it to a tangent? She said there's 2 options here. We can turn it into cosine over sine, or we can turn it into 1/tan. The answer says tan. So for me, the path that I'm going to choose is the one that's most likely to result in a tan. And what's most likely to turn into a tan is if I leave it as a tan. Now, granted, it's a 1/tan, but I'm going to turn into that. Why am I choosing that path and not the other path? Because I can see the answer. The answer says it's supposed to be tan. Do I know this is the right path? Well, I'm the teacher and I know what the slide's going to say. Yes, I know this is the right path, but I'm saying you're not going to know it's the right path. So you have to be looking at the answer always and saying, is this what I want to try to pursue? Okay. What were our 4 arrows? Well, they all had hope. What were our 4 arrows? Arrow number 1 was change something and hopefully something cancels. We just changed. We just used arrow number 1. Arrow number 2 was multiply by the conjugate, which one of you suggested we might want to try. Arrow number 3 was if you have fractions, you should add them or subtract them, right? And the last one, which was arrow number 4, we'll talk about later. Hey, look, I got fractions. I got 1 plus this. So one option is deal with the fraction. The other option would be multiply by the conjugate. Now you have a choice. Which one are we going to choose?
1 plus 1 over tan u tan u over tan u.
So once again, one option is to write 1 as tan u over tan u. And then look, I got nothing but tan u's, and look at the final answer. Tan u. Option number 2, multiply by the conjugate. If we multiply the conjugate, 1 minus 1 over tan u, that's a big hot mess. I don't want to go down that path because it looks messy. What's up? Yeah. So I'm going to choose the path that just seems like it's a little bit easier and it results, or I have nothing but tan u's. So I'm going to write this one on the denominator as tan u over, I'm getting a common denominator, right? Now add those two together. What do you get? Over tan u, right? Yes? Can you see it now? So as soon as I write, Seth says, hey, look, if I do a copy dot flip, guess what happens? We're left with tan u. So this one becomes easier if you can see in the future, see like what's going to happen. So your ability to think 1 or 2 steps ahead to see if something cancels is also critical. If you can't see 1 or 2 steps ahead, then you got to go down that path and see what happens. But as soon as we wrote that, you should, oh, look, something's going to cancel, and we wind up with exactly the answer we want. Once again, from the start, we had a choice. We could have written tangent as sine over cosine and cotangent as cosine over sine. Yeah, but neither one of those says tan u. So we chose the path that was, I don't know, at least pointed in the direction of the final answer. And we kept down that path. And it worked out in the end. You got to have a little bit of faith that, and you also got to pursue the path far enough, right? That you see whether it works or it doesn't work. Hey, we went 1, 2, 3, 4 steps. If you give up on step number 1, like that doesn't look like the path, or how do you know? Go down the path a few steps. Usually when you go down a bad path, you get a big hot mess really quick. And you're like, yeah, I got a big hot mess in the second step right here, but I had nothing but tan u's, and that was kind of like an indicator of maybe I'm on the right path. Okay. Scared? Ready to cry? Yeah. Good. Right. Number 5. Yikes. You should have a good sense of what we should do for this one. She says add, which means common denominators. Anybody see any other path to take? Once again, come up with a possibility, think it 1 step forward and see if it make a big hot mess or it kind of makes some progress. Any other suggestions besides Adam? All right, so let's add them. What's the common denominator? So what's the first fraction missing? What's the second fraction missing? This takes a while to write down. The red shows you what you're missing from each fraction. And now you have the choice of either actually doing the distributive property or not doing the distributive property. Remember I said it was one of your choices. Okay, so look at the top, try to think a step ahead and tell me whether you think we should actually multiply sine times sine and 1 plus cosine times 1 plus cosine, or just leave them alone. Try to think of what would happen if we did the multiplication and see if that at least gives me, I don't know, a chance of doing another step. So we're going to do the distributive property or not do the distributive property? Okay, so if you can't, you just got to pick one and see what happens. And if it doesn't work, well then you got to do it to see if it does work. For me, as soon as I multiply these, what do I get? And sine squared to me always tells me if I ever see a sine squared theta, I'm always looking for a, look what would happen if we multiply those. So for me, as soon as I see that I got a sine squared theta right here, I'm thinking, ooh, Pythagorean identity. As long as I get to a cosine squared theta, and look, if I do multiply those, I get a cosine squared theta. So I'm immediately thinking, look, I'm going to cancel something, turn it into a 1. Okay, the first one's easy to multiply. Who can multiply the second one in your head? Don't make me write x plus 1 on the board.
Oh, you want the factor?
Multiply.
Mhm. 2 cosine theta plus cosine squared plus 1.
That's the answer. Do you see it? Do you see it? Do you see it? What do I have now? What do I have? No, look at the top. What do I have?
Okay, so
Oh,
you see
you
those
just
cosine and sine theta. do
I
it.
just unfactored it. I multiplied it.
So that sine squared theta and that.
Look, I got a sine squared theta and a cosine squared theta right
That's
there.
one.
Those two equal. Okay, slow down, slow down. Make sure everybody else, right? So if I squeeze them together, it said, look, I got a sine squared theta and a cosine squared theta, and that equals 1. And I got another one right here, which equals 2. And look at the answer. The answer has a 2 in it. That's kind of how I knew that this was probably the path I need to go down to. So this in red turns into a 1. I got another 1 right next to it. 1 plus 1 is 2. I wouldn't write that step. I would really go to that step. Okay, look at your answer. We got some 2's. We needed a 2, but I need a cosecant. Cosecant is,
Wait, can you see those?
hey, I got a sign on the bottom. If only I could get rid of this right here. I'm looking at my final answer. I need to say 2 cosecant. I got a 2. I need a cosecant. I don't have a cosecant, but she says cosecant is 1 over sine. Well, I have a sine in the denominator. If I could only get rid of this, I would get a cosecant. So how are we going to get rid of 1 plus cosine? Look at the numerator. Tell me something smart. Look at the numerator. Tell me something smart. Say it out loud, though.
Wait, they have a plus cosine.
What do you got?
Yeah.
Factor out a 2. Factor out a 2 from the numerator. What are you left with? Yeah, but say the words. 1 plus cosine, and now the 1 plus cosines cancel. Once again, you got to think at least 2 steps. And now we have a 2 over sine, which is literally. Now we have a 2 over sine, which is literally 2 cosine. I'm sorry, 2 cosecant theta. Yeah. What time is it, bell ring?
Wait, how did it go? Okay, so I got 2 over sine theta, but how did it equal?
1 over sine theta is cosecant. So that would be 2
Oh,
times 1 over cosine theta, or sine theta, which is cosecant theta. So 2 times cosecant theta. All right. 2 more. I don't want to run out of time because we also want to do. I'm going to do these quickly. Stay with me. Hey, you see this big hot mess? We have lots of options. We can change all of these to many different things, right? I'm trying to get to 1, right? Either the way you get to 1 is by canceling, or you get a sine squared and a cosine squared. Do we have any sine squares and cosine squares to start with? No, so maybe something turns into it, right? So I'm going to change everything. Tangent is sine over cosine. Cotangent is this. I get this, yeah? You see the top? If we were to add the top, what we need, then I would be multiplying. Look what the first fraction's missing. So you'd be multiplying sine by sine, and I would get that sine squared that I'm looking for. And the other one, I would get a cosine squared, and there's going to be my 1. Okay? So the top, right? Do a copy dot flip. Don't do the multiplication yet. Do a copy dot flip. Good. Right, now multiply. See what it did? All I'm doing is showing you first fraction times this, second fraction times this as well too. But look what happens when I do the multiplication. I got a sine squared. The cosine squares would cancel and I'd just be left with sine 2 of them. So sine squared. And over here, these would cancel. I'd be left with and there's my sine squared plus cosine squared. Right? Cancel, cancel. And that's a 1. So on this particular one, other than the fact that tangent could be written as 1 over cotangent and cotangent could be written as 1 over tangent, that would be the other possible path to go down through. Multiplying by a conjugate, when I look at that, I'm like, I know I'm supposed to get to 1. I need to get a sine squared and a cosine squared. So I'm immediately thinking from the start that if I change things to sines and cosines, I am likely to get a sine squared and a cosine squared, and I did. All right, last one. What's the problem with this one? So you got to pick one, left or right. Like there's no clear cut which one I should work on. So you pick one. Left it is. It would work with right as well too. Okay. How many options do we have right now to mess with this? Well, what are the options? There's no squares here. There's no fractions to add. We're down to like 2 arrows. What 2 arrows are left? Well, if we change stuff, I could write sine as 1 over cosecant, and this is 1 over secant, and that doesn't get me anywhere close to that. What's the only other arrow left? The conjugate, right? So this is like, I don't know, the conjugate is all I got left. So I'm going to multiply top and bottom by 1 plus sine. Hopefully something magical happens. Hey, look, do you see what the conjugate is? Now look at the other side. What does the other side literally say? That's how I know that this is probably the path I want to go down. Okay? Okay, the bottom is already good to go, sort of. I just need to get rid of this word cosine. The top's got a big hot mess. So should I multiply or leave it alone? If I leave it alone, nothing happens. So therefore, maybe I multiplied, something magical happens. That's going to turn into 1 minus sine squared theta. Okay, 1 point on the quiz if you can figure out the next step. There's only one sign, top and bottom. What is the one thing I said from
1 equals sine, 1 minus sine squared theta is equal to cosine squared theta.
and you're done.
I gotta find.
Well, we got one more step,
Well,
right?
Cross out that, cross out the cosine, and then you only have 1.
And then we have 1, and that's what we wanted. Yay, done. This one was like the first one in the sense there really was only one thing to do. I'm not saying there was only one thing. This one actually had 2 things. But to change sine to cosecant and cosine to cosecant, I'm sorry, change sine to cosecant and cosine to secant, it just didn't seem like what was on the other side. So the multiplier by the conjugate kind of appeared to be the right thing to do. Okay. This is the quiz.